Okay, so this is our chapter on rational numbers and irrational numbers. So our first lesson is not a bad one. We hopefully by now know how to take terminating decimals and write them as fractions using their place value and making sure we simplify. So this is about writing repeating decimals as fractions. So we're going to have two categories. We're going to have one where the whole decimal repeats and one where only part of the decimal repeats. Honestly, between the two cases, we love this one. Pretty easy. The other one's kind of more annoying and has a couple more steps that we have to remember. So first, when we have a decimal where everything repeats, we're going to take the decimal, we're going to put it in the numerator of a fraction. Okay, so in our first example, we have 0.5 repeating with just the 5 repeating. So the 5 becomes my numerator. And then for every digit in the numerator, we're going to put a 9 in the denominator. So here we only had 5. So we only need to put 1 9 in the denominator. And we simplify if we can, which we can't. And so our answer for this is just 5 9ths. That's it. Okay, and if you don't trust me, grab that calculator, type in 5 divided by 9, and you will see that the calculator shows up with 0.5 repeating. Okay. The next one is 0.31 repeating, and the 31 is everything in the decimals repeating. So the 31 becomes our numerator. And now in this case, because there are 2 digits in the numerator, we're going to put 2 9s in the denominator. So 31 over 99. This one does not simplify. 31 is prime and it does not go into 99. So we know that we are done. And that is our answer. See, not bad. And then our last one, 0.27 repeating. We're going to take the 27 and make that our numerator. Since there are 2 digits in our numerator, we are putting 2 9s, so 99 in our denominator. But we are not done on this one because 27 and 99, we could divide them both by 9. Maybe you saw 3, but you do have to check and make sure, but 9 is the biggest. And 27 divided by 9 is 3. 99 divided by 9 is 11. So 3 over 11 is our final answer for that one. Okay, so love those. Super easy rule. Just remember those 9s in the denominator and you'll be good. So now the more annoying one where only part of the decimal repeats. Okay, I'm going to kind of go through the steps and work through the example at the same time so you can kind of see what I'm talking about with these steps. Otherwise, they don't quite make a lot of sense. So for this one, we have 0.26, but the 2 doesn't repeat and just the 6 repeats. So that's what I mean by only part of the decimal repeats. So what we're going to do first, and I should have notated this in your notes and I did not. So just kind of fill this in. Step 1 is really talking about our numerator here. Okay, so for the numerator, we're going to take the whole decimal, the entire decimal, okay, which in this case is 26, and we're going to subtract the part that doesn't repeat. So our first step here is to say 26, and the part that doesn't repeat is 2. Okay, that part right there does not repeat. So we're going to say 26, and then minus 2 is 24. That's the numerator of our fraction. So I'm going to write that down here to give myself more space. So 24. Now this is the trickier part and what you have to remember. So for every digit that repeats, just like we did kind of above, okay, where we're like, hey, we had 5 that repeated, just 1 digit. So we put a 9. Or in the 31, we had 2 digits that repeated. Okay, we put 2 9s. That is still true. So for every digit that repeats, we're going to put a 9 in the denominator still. So in this case, there is only 1 digit, the 6 repeating, so we're going to put 1 9 in the denominator. Okay, so that's still the same as before. So that's good. Okay, but now we have one more step, and that is to put, following the 9, after the 9, to put a 0 for every digit that doesn't repeat. So once again, we had that 2 in the decimal that doesn't repeat. Okay, so there is 1 digit that doesn't repeat, and we are going to put a 0 for every time that happens. Okay, so here we end up with 24 over 90. And once again, if you're not entirely sure, or what's nice if you don't quite remember the rule, but you kind of know how it's supposed to look, you can try it. Okay, and I just did it on my calculator. Okay, we can see that we get that 0.26 repeating, which is nice. Okay, so I know I've set my fraction up correctly, but I do see that they're both even and we are not done here. So I'm going to divide them both by 2. We'll start there. That gives me 12 over 30. But now I see that they're also both divisible by 3. And we end up with 4 over 15. And once again, if you're not sure if you simplified correctly, just type into your calculator 4 divided by 15, and it does end up being what we wanted it to be. Okay, so 4 out of 15. So just to kind of go through those steps one more time, okay, we took the whole decimal, which was 26. We subtracted the part that didn't repeat, which was 2, and we ended up with 24. That became our numerator. For every digit that repeated, just like before, we put a 9 in the denominator. So we had one digit that repeated, so we put a 9 down there. We also had one digit that didn't repeat, so we put a 0 after it, and then we simplified. Okay, here we have 6.617 with just the 7 repeating. So our first step is take the whole thing, 617, and we are subtracting the part that doesn't repeat, which is the 61 in this case. So we have 2 digits here that don't repeat. And I'm going to just use my calculator to figure out that 617 minus 61 is 556. So that becomes the numerator of our fraction, goes right there. For every digit that repeats, we put a 9 in the denominator. So we only had one digit that repeated, so that's 9. And we had 2 digits that didn't repeat, which means we have 2 zeros. So that is the starting setup of our fraction. But we can definitely simplify a little bit here. So I happen to know that these are both divisible by 4. So 556 divided by 4 is 139. 900 divided by 4 is 225. And now let's talk about, like, how do we know we're actually fully simplified? Because our numbers are getting kind of big here. So one way to do that is to talk about prime factors. So kind of figure out, like, what are the basic numbers that a number is made of. So 225, I'm going to use my calculator for this to check. So 225, it ends in a 5. So I know I can divide it by 5. I'm just going to do this on the side over here. So this, okay, is really 5 times 45. Okay, 45 would be 9 and 5, right? And that means that 9 is 3 and 5. Sorry, 3 and 3, not 3 and 5. But we already had 5s there before. So really, if I take that 225 and I break it apart into its basic pieces that are being multiplied, I got 5s and I got 3s. So that means only a couple things can happen here if we're trying to simplify, okay? That means if we're going to be able to divide out something that's common, 139 would have to be divisible by 3 or 5. And I know it's not divisible by 5 because it doesn't end in a 5 or 0. Okay. I know it's not divisible by 3 because if I add up the digits, they don't add to a multiple of 3. Or worst case scenario, once again, just use your calculator and see if you can do 139 divided by 3 to get a nice number. Okay. And the only other thing then, if they don't actually have any common factors that could possibly happen is, well, I guess you would see it's a common factor, but see if, like, this one goes into that. Like when 6, if it's 6 over 18, 6 would go into 18, but in this case it doesn't. So when you break it apart into its most basic pieces, that's how you can check to see if those pieces are common to the other one as well. So this one, there is nothing else we can simplify here. That, as crazy as it looks, is our final simplified fraction that gives us that decimal. Okay, and then real quick, okay, just to talk about some mixed numbers here, because these tend to freak you out and it's not bad at all. So if it's 3.4 repeating, okay, it is we're still going to do the 0.4 repeating like we did above. So 4 is our numerator. There is one digit that repeats. That's our denominator. So 9. And if it's 3.4 repeating, or 3 and 4 repeating, that 3 that's in front of the decimal just becomes the 3 in our mixed number. So that is just still the whole number. That part doesn't change. So just do the decimal like you have and keep the number out front. For this one, we're going to do 0.631 with the 1 repeating, using that more annoying step. So we're going to do the whole decimal, 631, minus the part that doesn't repeat, which is 63. We get 568. Okay, we're going to do, I'm ignoring that -7 for now, but we have 568 as our numerator. One digit repeats, so we have a 9. Two digits don't repeat, we have 2 zeros. We can simplify, let's just do by 2 for now. So 568 divided by 2 is 284. 900 divided by 2 is 450. I can do another 2 because they're both still even. So that would be 142. And that'd be 225. So I end up with that 225 again. So I know it's, 3s and 5s. And 142 divided by 2 can't be divisible by 3 or 5. So it appears that's our final part, but we're not going to leave that because we need to make sure we also include the part that was in front of the decimal, which was a -7. So we're still just going to keep that -7. So even if it's a negative out front, that negative just follows it and becomes part of that integer part of the mixed number. Okay, so mixed number is really not anything crazy. Okay, so that is how we do our repeating decimals to fractions. And we are going to practice.